Hello, we will learn how to draw a cycloid. The problem statement is given here. Draw the locus of a point on the periphery of a circle having diameter of 50 millimeter, which rolls on straight line path. Name the curve and draw a tangent and normal to the curve at any point Q on it. It is given a circle is rolling on a straight line path. We need to trace the locus of a point on the periphery of a circle. Therefore, the curve is a cycloid. How to draw for the given data? At any convenient position, preferably on the left end of the drawing sheet, draw a circle of diameter 50 millimeters. So this circle is the generating circle. The next step is to draw a straight line path. Straight line path is nothing but a straight line. But what is the length of the straight line? We can assume the circle is going to complete one revolution. That means it will rotate through 360 degrees. We know for one revolution, the circle will travel a distance equal to its circumference or the perimeter. Therefore, the length of the straight line should be pi d, that is the circumference. This is equal to 3.14 multiplied by 50 is equal to 157 millimeter. Now, draw a line tangential to the lowermost point of the circle to a length of 157 millimeters like this. So this is the circle, this is the straight line path over which the circle is going to roll. Next, divide the circle into 12 equal parts. For that, after setting the minute drafter scales parallel to the edge of the drawing sheet, bring the vertical scale of the minute drafter to the center of the circle and draw a vertical line passing through the center of the circle as shown here. The minute drafter vertical scale is brought to the center of the circle. Now through the center draw a vertical line like this. So the vertical line is drawn. Next, using the horizontal scale of the minute drafter, draw a horizontal line through the center of the circle like this. Now the circle is divided into 4 equal parts, but what is our aim? We need to divide it into 12 equal parts. How? When you divide a circle into 12 equal parts, each segment or the sector will have an included angle of 30 degrees. Therefore, we use mini drafter and 3060 set square to draw or to divide the circle into 12 equal parts. What you need to do is keep the longest edge. So this is the longest edge of 3060 set square. Keep this longest edge intact with the horizontal scale of the mini drafter and move such that the long edge of the set square is at the center or it nearer to the center. Now using this long edge, draw a line like this. Now move the mini drafter and 30-60 degree set square such that the shortest edge of the set square coincides with the center of the circle. Now through this edge, draw a line. This. Now coincide the shortest edge of the set square with the vertical scale of the mini drafter and draw a line passing through the center of the circle using the longest edge of the set square like this. Finally, coincide the shortest edge and the long edge of the set square with the horizontal and the vertical scales of the mini drafter respectively and draw a line through the center of the circle using the longest edge like this. Now the circle is divided into 12 equal parts. Name the points on the circle like this: 1 dash, 2 dash, 3 dash, 4 dash, 11 dash. And the 12th point is named as P, which is the starting point for the straight line. The other end of the straight line is also named as P. Divide the line PP into 12 equal parts. Why 12? The number of divisions on the line PP must be equal to the number of divisions on the circle. Already we have divided the circle into 12 equal parts. Therefore, divide the line PP into 12 equal parts and name the points as 1, 2, 3, 4 up to 11, and the 12th point is P. Next, draw horizontal lines parallel to PP from the points 1 dash, 2 dash, 3 dash, 4 dash up to 11 dash on the circle. All the lines must end at P. Therefore, there is a vertical line at P. If you observe, line from 11 dash pass through 1 dash, line from 10 dash pass through 2 dash, line from 9 dash pass through 3 dash. Similarly, 8 dash to 4 dash, 7 dash to 7 dash through 5 dash. Draw vertical lines from points 1, 2, 3, 4 up to 11 until they meet the horizontal line through 9 dash 3 dash. So from each point there is a vertical line until they meet the horizontal line through 9 dash 3 dash. That is the horizontal line through the center of the circle. Now name the center of the circle as C and the other end of the horizontal line through the center as D. So center is D, the other end of the horizontal line is D. Now name the intersection of the vertical line from 1 and the line CD as C1 and the intersection of vertical line from 2 and the line CD as C2, etc. like this. C1, C2, C3, C4 up to C11. So C11 is nothing but the intersection of vertical line from 11 and the line CD. So that point is C11. With C1 as center and 25 mm radius, cut an arc on the horizontal line through 11 dash 1 dash. So take 25 millimeters in your compass, fix C1 as center and cut an arc on the horizontal line 11 dash 1 dash and obtain point P1. So the intersection of the arc with the horizontal line 11 dash 1 dash is P1. Follow the same procedure using C2, C3, C4 up to C11 as center. Obtain different points P2, P3, P4 up to P11. Here, take 25 millimeters as radius in your compass, fix C2 as radius, cut an arc through the horizontal line 10 dash 2 dash and obtain point P2. Fix C3 as center, 25 millimeters as radius, cut an arc on the horizontal line through 9 dash 3 dash and obtain point 3, that is P3. Fix C4 as center, cut an arc on the horizontal through 4 dash, obtain P4. C5 as center, cut an arc on the horizontal through 5 dash with 25 mm radius, obtain P5. Similarly, obtain P6 with the C6 as center, 25 mm radius, with C7 as radius, with C7 as center, 25 as radius, cut an arc on the horizontal through 7 dash and obtain point P7. With the C8 as center, 25 mm radius, cut an arc on the horizontal through 8 dash, obtain P8. With C9 as center, 25 mm radius on the horizontal through 9 dash, obtain point P9. Now with the C10 as center, 25 as radius on the horizontal line through 10 dash, obtain P10. With the C11 as radius on the horizontal line through 11 dash, cut an arc and obtain P11. Similarly, with the D as center, 25 mm radius, cut an arc and that arc will pass through this point P. That's why it is not shown here. Similarly, with the C as center, that means the center of the circle, with the 25 mm radius, cut an arc and that arc will pass through point P. It's not shown here. In the drawing sheet, point P on the left hand side is the starting point of the cycloid, and point P on the right hand side is the end point of the cycloid. That means the circle starts rotating from this position. When it completes, the point P will reach the bottommost position again at a distance of 157 millimeters from the starting point. P1, P2, P3 up to P11 are the positions of point P at different angles. What is the angle? We have divided the circle into 12 equal parts. Therefore, each sector has an angle of 30 degree. When the circle is rotated through 30 degrees, point P moves to P1. When it is rotated through 60 degrees, it is P2. When the circle is rotated through 90 degrees, point P will reach P3. When it is rotated through 120 degrees, point P will reach P4. Like that it goes. Therefore, P1 to P11 are the intermediate points. P is the end point. One at the left end, the other one is at the right end. To complete the locus, or to draw the locus of point P, we need to join all the points using a smooth curve. And this curve is cycloid. The last step is to draw the tangent and normal to the curve at any point Q on it. Position of point Q is not given. Therefore, mark a point Q on the curve arbitrarily. So the position is arbitrary. So this is Q. It can be anywhere on this cycloid. With the Q as center, 25 mm radius, cut an arc on line CD and obtain X. What is this? Take 25 millimeters in your compass, fix Q as center, cut an arc on the line CD, and the intersection of arc with the line CD is X. Draw a vertical line from X and obtain N. Now join N and Q and extend. Mark the end of the extension as N dash. Now this N dash is the normal to the cycloid at point Q. Now draw a line perpendicular to N dash through Q to obtain the tangent. So the tangent line is denoted by the symbol T dash. So this is the complete sketch of the problem. Here the dimension 50 is shown. And in this problem, we have traced the locus of a point on the periphery of a circle. The point we considered is P. So P is the point at the periphery, and we assume the circle rotates in clockwise direction and the curve is drawn for one complete revolution. Thank you.